Hello everyone, my name is Hwee, and today I'm going to share with you about how to see data in multiple dimensions. And this links to hierarchical indexing and pandas and how do you visualize that. So why am I interested in this topic? It has something to do with my background as a data engineer. I'm a data engineer based in Singapore. And well, I have a background in aerospace engineering, and then afterwards I decided that hey, I want to pursue my interest in competition modeling, and that's where I also had to handle quite a bunch of data with multiple variables, multiple dimensions, something like what I do right now. And because I'm a data engineer and I do quite a couple of data pipelines and I use quite a lot of pandas, so I love using pandas. And once in a while, I do contribute back to pandas as a way of giving back. And well, before the whole pandemic situation, I'm actually a pretty active local, pretty active participant of the local tech community. And I volunteer as a mentor at Big Data X, whereby we conduct data engineering workshops for data professionals who are interested to pick up some data engineering skills. Now, as I mentioned earlier, the data I actually have to handle data that has multiple dimensions, multiple variables, and this data do exist in multiple dimensions. It's about whether we see it or not. And it can get a little bit tricky to see them. So let me give an illustration of what I mean by dimensions in data. So let's look at the simpler case of one-dimensional data mapping into an output. Okay, so question now over here is how much money are we making on item A, whereby item is the variable and then the money that we're making is the output. So if we look at item as one dimension, and then we have the money that we're making as the output. And this brings our solution space as a 2D, something like a square. So you have a 1-dimensional variable mapping to a 2-dimensional solution space. Now let's add another dimension to this question. How much money are we making on item A from vendor B? So now your variable space is 2-dimensional, and you have an output that you are trying to map from a 2-dimensional space. So you are mapping a 2-dimensional space into a point out of the dimension, and then this brings you to a 3-dimensional solution space. And the point that you're looking for is going to be somewhere in a 3-dimensional space, and that is somewhat like a cube. So you have 2-dimensional variable space, and then your solution space is going to be a 3-dimensional cube. Looks reasonable, right? You can somewhat visualize a cube. Now, how about another dimension to this problem? How much money are we making on item A from vendor B and branch C? Okay, so now our variable space is a 3-dimensional space. And from this 3-dimensional variable space, we're trying to map to another dimension in the solution. So I have a 3-dimensional space. I'm trying to map to somewhere in the solution, right? But then, wow, you're going to get a 4-dimensional space. It's a solution space, and that's going to be like a 4-dimensional cube. So something like a tesseract. Yeah. So you look at the rotating cube, somewhat like rotating time, like you wonder like, wait, where is the solution that I'm looking for? Wait a minute, I can't visualize 4-dimensional. What's this cube doing? It's moving around. So you get the idea. If you're moving into more dimensions beyond 1D, it gets more challenging to visualize data. Now, how do we visualize our data, this brings me to the concept of hierarchical indexing, also known as multi-index and pandas. So how does multi-index work? According to the documentation and the pandas, you can see that multi-index is defined as a hierarchical analog of the index object, which actually index where your particular element is and a data frame. And multi-index stores combinations of multiple index levels into an array of tuples. But that's in contrast to index object, whereby it stores your index level, a single index level, into an array of elements. Then something like in integer, like a number, like integer or string. So what do I mean by combinations of multiple index levels? You can see that it's somewhat similar to iter2 product, whereby I have level 0 iterable, level 1 iterable. Example, like, level 0 iterable could be like 1, 2, 3, and then you have a level 1 iterable like ABC. So what we are getting will be all the possible combinations they can get from those two levels. Something like 0A, 0B, 0C, 1A, like 1A, 1B, 1C. You get the idea. So a multi-index object will have the following properties. So number one would be the number of levels, because you need to know how many levels are there in your multi-index. Next, you need to know what are the defined levels of an index, including all the unused levels. And why do we need that? It's mainly for performance purposes, in case you need the index anyway. And then we also need to know what are the names of each levels, so that we can differentiate between the levels, besides just level 1, level 2. Last but not least, we also have the level labels, also known as codes, which defines what are the level values that are used in the multi-index data frame. So when we look at multi-index data frame, for example, and I look at the type, I'm going to get a multi-index. This data frame has 2 levels in the multi-index, and I look at the n levels. And then we look at what are the levels in this multi-index, and then we see that we have a frozen list containing the possible elements at each level. So you see that you have the list of possible elements of level 0 index, and then similar for the level 1 index. So the frozen list, they are sort of fixed unless you do something to change the multi-index. Then we have names of the multi-index. So the level 0 index is named as first, level 1 index named as second. Now when we get the level values for the level 0 index, we're going to get what is being used. So in this case, the levels that are being used in level 0 index is AA, B, B, C, D. So that's what you get, the index called AA, B, B, C, D. And then you also see the name of the index. Now, when we talk about codes, this is where it gets a bit more interesting, because that's how you define what are the levels that are being used. So when we look at codes, we see a list, and you look at, so for example, we look at level 0 index, and then you look at the first list and the whole nested list. So you see that they're numbers, but you see a number. So those numbers refer to the positioning of the particular element in the index for the particular level. So for example, when we look at the level 0 index, you have A, B, C, D, E, right? A, B, C, D. So since Python uses 0 indexing, and then you have this list of A, B, C, D, Well, you can see it corresponds to the positioning. So 0, 0, 1, 2, 3 corresponds to A, A, B, B, C, D. So I will show you I will actually illustrate to you later on the talk. So now we understand, well, now we know like what multi-index contains, what's the properties. So it's very important for us to understand how to work with multi-index. And with that, let's look at an example. So imagine that we have two buyers buying goods from 5 vendors. And then the aggregated data frame that we have includes the number of transactions as well as the total amount of the transactions. And as you can see in this data frame, it's a multi-index with 2 levels, whereby the names are vendor and buyer, and then you have the level 0 elements and the level 1 elements. So take a look at what's in the level 0 and level 1, then the corresponding list of elements for the level. And you can see that we're trying to set how we are sort of using the index. So we use set codes to define it. Okay, so in this case, I'm trying to arrange my data frame in particular order, but alternatively, I can also do a set code to sort of define how I want to arrange my multi-index. So in this case, right, what is more interesting will be my level 0 indexing. So if we look at the right, and if we look at the figure that over there, which represents levels. So you have the vendor and the buyer, and then for this level, you can actually see what's the elements there. And then I've actually included what's the indexing in the list corresponding to the levels. So for vendor, we have A, B, C, D, E, and then it corresponds to, so we have 0, 1, 2, 3, 4 in terms of 0 level index, 0 indexing in the list. And C 0, 2, 3, 4, 0, 1, 2, 3, 4 corresponds to A, C, D, E, A, B, C, D, E. So you can see that set codes defines the order of the labels according to the positioning of the label in the defined level. So I did my set codes and stuff, but I need to do something. Right? And task is that I would like to get the overall aggregate for each vendor. And for that, I need to reshape my multi-index by doing some unstacking, stacking. And this brings me to the stack and unstack function. Okay, so when we look at, first, data frame stack shifts the level of labels from the column to the row. And so if you look at the column indexing, right, we have A, B, and then we have one column level, and then in this example, you have two row levels, and then the names are first, second, and then you have level 0 and level 1 elements. So what stack does is that I have the column level, and I'm trying to slot that level into a row level. And yes, so when I shift it down, then I'm going to have to map my elements in the data frame according to the combination of indexes that corresponds to the particular element. So I need to maintain the integrity and the correctness of the data frame when I try to reshape it. So you look at the original order of the data frame, you have A, B, and then 1, 2, 3, 4, 5, 6, 7, 8. But I still need to maintain the mapping when I am reshaping it. So now I have to maintain it, and then the output is going to look like a series with 3 row levels mapping to the element, and then your name, and you have the additional row level having none as a name because we didn't really define what's the name of that particular index. But yes, we managed to shift a column level into a row level, and the total number of levels are maintained. And to summarize, the stack function is what shifts a column level into a row level, something like this. So it's not that you are going to definitely get a series, because it really depends on how many levels are there in your column levels and your column index. So you get the idea. So unstack is the inverse function of stack, where it shifts the level of labels from a row index to a column index. So it's the inverse function. And what it does is, okay, I see the row index, right? I shift it up to a column index. And by default, unstack will shift the last row index up. But if I don't want to shift the last index up, I will have to define which level I want to shift up. So this actually applies also for stack when you have multi-index for columns. So in this case, right, I have multi-index for rows or my row levels, and I'm trying to shift my level 1 index up. So I need to use unstack 1. And yes, this is basically to illustrate that stack and unstack are inverse functions in general. And let's go back to an example of the aggregate data frame, whereby you have the column levels and the row levels. And then when I do a stack, I shift the column levels to the row levels, and then now I have all the row levels and no column levels. But because I'm interested in getting my aggregate for each buyer, and then I want to get the total of the buyers, so I need to shift the buyer row index up. And after which I will be able to calculate what's the aggregate total across the buyers, and I get the overall aggregate for each vendor. And for that, I just do a sum across the vendors, and I get what I want. So now we need to visualize what's the multi-dimensional data like, and we also need to have some considerations on how many dimensions are there in your visualization. So for a series with a single index, like a one-dimensional data, that's a univariate analysis, and your visualizations are going to be 2D. So because you have a one-dimensional data trying to map the output, right? Just like what I've explained in my analogy. But for data with multiple columns and levels, that's going to be a multivariate analysis. So does that mean that our visualizations have to be 3D or more? I will explain to you what's the problem with 3D visualizations. So if you look at the left side, I really can't see what's at the back, I can't really see how they stack up. I mean, it looks messy, but I really can't see, I kind of compare the 3D bars. And you look at the right side, right, I don't even know where the points are. I mean, it's spatial, I can't really see how without a proper labeling. So, okay, let's have stack bar graphs. But, even if I try to arrange them into a descending order, but is that really enough? Because sometimes, right, I don't want to look at what are the What's the height of each of those bars? And I'm not looking at total. I want to look at like some other element. Then, well, was that really enough? If I just look at the static, probably not enough. And that's whereby I need to be able to interact with those multiple dimensions, and hence I decided to, and hence I came across Plotly Python. So it's an interactive web-based visualization that's built on top of Plotly JavaScript library, Plotly.js. And for typical usage, there's actually a high-level API available known as Plotly Express, and it can be displayed in the Jupyter Notebook or saved as a standalone HTML with all the interactive features because it's JavaScript. It's so to use Plotly Panda Express backend with Panda spotting as of 0.2 as of Pandas version 0.25 and above. What you do is to set my backend as Plotly. Okay, so I tried it. But then I ran into some problems with trying to plot my multi-index data frame. Because when I try to do a plot on the multi-index data frame, I get this type error. It's not supported at the moment, which means I need to have a get around for multi-dimensional visualization. Okay, so I need to reset the index to get my multi-index into a single index so that I can use Plotly Express. And then if all else fails, then I have to use Plotly ground objects, but then the documentation can be very tedious because it's actually primarily a JavaScript package. And Python is not really well supported. You can get very convoluted trying to navigate the documentation. And that's going to be something that's for a totally different topic. And if it really all else fails, plotting multiple graphs are free. So just plot multiple subplots of the same data in different perspectives. So for example, I like to plot stack bar charts in Plotly Express. Then I use my usual Plotly Express, and then I plot the bar chart. And with that 2-3 lines, I can get an interactive HTML chart whereby I can point at where I want, and I can look at what's the breakdown, which makes trying to interpret the multidimensional data a bit easier. So some key takeaways from this talk will be that in pandas, there's a way for you to work around with multidimensional data that's called hierarchical indexing or multi-index, and how it allows working with multi-dimensional data is that it represents higher dimensional data as lower dimensional data structures. And when we're looking at visualizing our data, there are actually multiple ways of viewing data in multiple dimensions. So there's actually no absolute wrong answer. It's really about how you view the data from a certain angle and a certain dimension. Okay, so yeah, that's all for my talk. And yeah, feel free to reach out to me via the following social media, my website, and yeah, ending off with a tesseract, which represents three-dimensional data mapped into a solution space. Thank you, and hope to see you next time.